This is kind of a trade-off we're facing. Either it's going to be very capable, independent, and creative, or we can control it.
Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. Joining me today on How AI Happens is an associate professor at the University of Louisville, Dr. Roman Yampolskiy. Doctor, welcome to the podcast. How are you today?
Great. Thanks for inviting me.
I'm really pleased you're here. You are broadcasting in, it looks like, from your office at the University of Louisville. Is that correct?
That's right.
So if we get any errant knocks on the door, people, trying to come in for office hours, tell them to subscribe to the podcast if they want to hear from you.
Will do.
I have so much I want to go into with you because you have kind of touched a lot of different areas in this space. And so before we get into the weeds here, would you mind to set some context for the folks at home and share a little bit about your background and your studies and kind of how you wound up in your current role at Louisville?
I'm a computer scientist. I did my Ph.D. on behavioral biometrics and kind of naturally started looking at behaviors of not just human agents, but also bots. And the bots keep getting smarter, so we need to keep up. Very natural progression to analyzing artificial intelligence, how it improves, how we can keep up, predict its behavior, explain it, and maybe even control it.
You have a PhD in computer science and engineering, I believe. Was your dissertation in behavioral biometrics? Do I have that correct?
That's right. I was looking at game strategy as a novel behavioral biometrics, specifically online poker.
Got it. What did you learn?
People have unique behaviors, and so do AIs. If they're not good enough to randomize, you can abuse that repetitive behavior and make some money.
That's maybe a topic for a separate podcast episode, or maybe one where we're not being recorded. Can we start with your recent book that you published, Artificial Superintelligence, A Futuristic Approach, where you spend a good amount of real estate in the book speaking about the importance of safety engineering in artificial intelligence. Would you mind defining AI safety engineering and perhaps even distinguishing it from terms like explainable AI?
Sure. So for about 50 years, AI was all about making it work. We didn't care about much else. We just wanted something we can, sell, products, services. We started getting some success, and now we realize it's not enough to just make it work. It has to work in real world. It has to not violate privacy expectations. It has to be bias-free. It has to be safe if it's controlling cyber infrastructure. So more and more as capabilities of those systems increase, we realize possibilities for damage are also significant. And there is very little research, at least until recently, on how to address it. So when people say we want to create very capable intelligent systems, they kind of imply that they want systems which will not harm users, will not embarrass the company producing it. But it's not something you get as a side effect if you not specifically work on getting that part of a system to do it just right. And a lot of times you don't know how it might fail. You don't expect certain side effects. Companies get surprised. And so AI safety can be kind of divided into two sub-components. Systems we have already, narrow AI, spell checkers, text prep, anything like that, which fail to deliver successful product or service. Not a huge deal, mostly inconvenience. People worry about, as I said, bias. They worry about loss of labor, technological unemployment. And then the second part is future AI, systems we don't have yet, but which we anticipate will create eventually, which are as smart as people or maybe smarter. And they are general. They can make mistakes in any domain. They can impact all sorts of critical systems, stock market, military response. Really, anything is controllable by software. So that's where the big concerns are about existential risks, suffering risks. So we're kind of gradually learning how to deal with what we already have, privacy concerns, how to make sure that data doesn't leak information about whoever is providing that data. And bias is another very big one. Most companies took some sort of pledge about not deploying AI which is biased against certain races or genders, but all of it is kind of short-term, near-term problems. Long-term, we want to make sure we don't create something which is more capable than us and completely out of control.
That last piece is interesting to me because some of the concerns you laid out there, privacy controls or possibility for bias to creep in, this has been a risk of technologies previously, right? Not just with artificial intelligence. Do you think that the stakes are higher, that there's a greater need to put in guardrails, for lack of a better term, in AI specifically as compared to other tech?
Right, so most tech is tools. You have tools which could be very dangerous, especially in the hands of a wrong person, but AI, at least at human level, is an agent. It's an independent entity which makes its own decisions, can decide and explore new pathways to achieve its goals and come up with new problems which were not originally part of a design. So it's a very different situation. Tools, we kind of know how to deal with. It's more of a deterministic set of problems we can consider. Okay, those are the issues we need to worry about. With agent-like system, it's open-ended. It can do really anything in any domain, and so it's much harder to test it, to debug it, to make sure it will function as expected in novel situations.
Right. The risks are really limited by your own imagination in the case of an agent, right?
Not yours, the system's. That's the problem. If it was mine, I would be able to predict some of it. The system is smarter than me, and that has much bigger set of possible domains of influence.
Yeah, that's well pointed out. And what kind of safety would you engineer in this case? And if the technology has a possibility to think beyond you, what are the guardrails you can put in place?
Welcome to my research. It's been 10 years and I have very few solutions and mostly new problems.
What are some of the new problems? Let's start there, I guess, and work backwards.
So every time we kind of decide, okay, in order to control those systems, we'll need certain tools. We need to be able to explain how they work. We need to predict the decisions they make. We need to be able to verify software. And there is about a dozen others I can talk about. For each one, we discover there are well-known proval results which say you cannot do that. You cannot have, for example, a much smarter system which we can predict in advance in terms of all the decisions it will make. We can kind of understand, okay, the chess program will win, but we have no idea what moves it will make. So details are obscured from us. If a system tried explaining what it's doing or how, it will either have to simplify the actual answer so we can get it, or it will be so complex we will not comprehend the answer. There are similar limitations from many domains which we feel would be part of that solution. Economics, political science, psychology, they all have their own kind of well-known, okay, voting. We know there are limitations to every voting system. Somebody will not be happy with the result. Mathematics, we know there are self-referential proofs which cause, problems with verification. And so on and so on. We have a survey paper looking at dozens and dozens of such results.
So it would then stand to reason that you would need an expert within each individual subfield to design rules that would be limiting or increase safety based on the application of the tech, right? There's no way you could kind of put an umbrella over AI as a technology writ large and expect it to perform and institute those safeguards. Is that correct?
It's definitely useful to have very diverse set of cognitive tools to work in this field. Pretty much everyone can contribute something. There are some ideas for maybe trying to restrict capabilities of a system to the level of human experts, so we are more competitive, we can better understand what it's doing. But even that type of restriction is not obvious how to actually do that. The system is very likely to find a workaround any such obvious limitations.
Definitely. And on the topic of limitations, just in terms of implementing accountability, you have this challenge of incentives, right? Like particularly in companies want to make money and they can deploy tech to do so. Would there need to be some kind of governing body, like outside of even state governments? I guess those sort of non-governmental institutions and nonprofits do exist, but in addition to, practical means, wouldn't you need some kind of oversight board?
So it really depends on how difficult the problem is. If it's a huge problem and it requires computational resources in billions of dollars, something like Manhattan Project, then government supervision makes sense. You can supervise Amazon, you can supervise large companies like that, Google. If it turns out that the problem is much easier, somebody comes up with a very clever algorithm, you can do it on a laptop in your garage, then governance is kind of useless. It's a security theater. We made spam illegal, we made computer viruses illegal, it makes no difference, you still do it. So it really depends, and we don't know how hard the problem is. Right now, the best results we get is when we scale our systems. So scalability definitely brings results. So maybe there is a chance to employ some governance in terms of restricting available compute to large projects.
Yeah, that is certainly a challenge. The increasing decentralization plus the commoditization of processing power. How would one enact any safety in a world where anyone can do this in their garage?
It's possible that we can't. So everyone kind of assumes that the problem is solvable and it's a question of give me a little more money and I'll solve it, give me another grant. But it's quite possible that the problem is unsolvable. That's actually part of my research. Control problem could be solvable, maybe. It could be solvable in some specific variation of it. So you have direct control, you have ideal advisor where you have the smarter system deciding for you. You have kind of hybrid variations on it. So maybe some of them are not solvable at all. Maybe it's undecidable. Nobody has published anything explicitly proving that, okay, this can be done, we can control smarter systems, or even the opposite. So what I published is a lot of kind of evidence from other fields and argumentation, but it's not a solid mathematical proof that for every system, any design, it would be true as well. So it's still open area of research.
Right. Where are some areas that you see problems that are solvable?
So anything kind of narrow domain where we can define what the space of possible solutions looks like, and we don't have to worry about creative answers. We can kind of make sure the system follows what we expect. Anytime we give it enough independence to be creative, to think out of the box, that's where we don't know how to specify good versus bad. We don't know how to explain what good answers look like, what ethical, moral answers look like, and it's not obvious that we wouldn't even agree with other humans about what good answers look like.
Right. And isn't that thinking outside the box, isn't that kind of an ultimate goal of developing artificial intelligence? In a simple definition, if artificial intelligence was to replicate human cognition or human behaviors, then surely creativity, developing, recursively adapting, evolving, growing, changing, this is all part and parcel with it. So would the nature of AI in that case then prevent it from engendering solvable problems?
Right. So this is kind of a trade-off we're facing. Either it's going to be very capable, independent, and creative, or we can control it. For some problems, even important problems like protein folding, it seems that we can have systems which are not general, not as smart as humans, and still they can solve that type of important problem for biology, for medicine. But maybe there are problems we really need superintelligence, general superintelligence. And in that case, we have to kind of give it more creative freedom, but with that comes danger of it making decisions we will not like.
In that latter case, do you think that there needs to be a decision made whether we should, right? I keep coming back to this question in this show, which is when it comes to the ethics of artificial intelligence, when it comes to explainable AI, this like abbreviated quote from Jeff Goldblum in Jurassic Park, you asked if you could, you didn't ask if you should. Are we going to reach a moment with artificial superintelligence where we kind of have to decide where this tech is going? And is that reasonable for us to expect there to be that kind of referendum?
It seems like we're unlikely to be able to decide not to do it. The pressures, which are economic, prestige, malevolent actors, the same people who write computer viruses, doomsday cults, crazies, somebody's going to press that button. So it's very unlikely that we can just have democratic vote and go, nope, we're not doing it. It doesn't work.
What do you believe are some of the risks? I mean, we can go as dystopian as you care to here, but in the near term, perhaps, what do you think are some of the risks of not prioritizing safety engineering?
So I have a paper in which I survey AI accidents, historic accidents, and this is all for tool AI, for narrow AI systems. And usually the formula is if you make a product or service to do X, it will fail to X. Whatever X means, driving a car, spell checking your text messages, doesn't matter. It fails at that task. So if we project it to general systems, it fails at everything. So if you have a system controlling all your cyber infrastructure, it can destroy your economic power through crashing stock market. It can start to win or lose a war, nuclear war possibly. And those are things which we can predict. Those are known unknowns. We don't know what it's going to do, but we can understand those things. There are also unknown unknowns, where a superintelligence is smarter. It comes up with something out of the box we didn't consider, which is also very bad potentially.
So the risks are really just, as you point out, whatever the task is that could be failed, right? What are the stakes of the failure of any given task? Because we'll be deploying this technology conceivably for any given task, right?
Absolutely. The more capable the system is, the more it is deployed, the more of a damage it can cause. Absolutely.
I want to ask about you personally, Doctor, because you have this very interesting experience, a lot of background in several different applications, behavioral biometrics, as we mentioned, but also, game theory and games and neural networks, just to name a few. It strikes me you could have lent your expertise perhaps to any application of artificial intelligence. So what made you decide to focus on this area in particular?
It seems like it's the most important problem. It's kind of the meta solution to all the other problems. If you can make friendly, well-controlled superintelligence, everything else is trivial. It will solve it for you. Other existential risks, climate change, biohazards, and also any products or services. So as long as you have that tool done right, everything else is easy.
It sounds so simple when you put it that way. Everything is sort of downstream of making sure this technology works for us, I suppose, is the point there. So if I'm listening to this and I'm, a practitioner, I'm developing artificial intelligence, what are some questions I can ask myself as I'm developing tech to make sure I'm doing so in a safe capacity?
So if you are about to release a product or service, definitely consider in what ways it could be misused, in what ways it can fail. We see some examples again in the paper I mentioned where companies released a product. It was obvious to anyone who takes 5 minutes to think about it what the consequences would be, but they didn't. And the company gets embarrassed, they have to pull the product, the whole backlash, the industry is unhappy. So it's a good idea to kind of think about those things if you're just working on some narrow product or service. If you're doing general intelligence, that's a whole different story.
And it's related to this notion of accountability, because if you are an individual on a team of individuals all working on a product, and you have a boss and a boss's boss and shareholders and whatnot, it's easy to say it's not my problem or it's not my fault, right? Like, who is truly accountable for the fallout from this tech failing? You wrote a recent paper, The Unownability of AI, Why Legal Ownership of Artificial Intelligence is Hard. And what stood out to me, accountability is the point here, right? Like, when this fails, who do we blame? It cannot be that we just fine a company. But you brought up this point towards the end. I'll just quote it back to you if that's okay, where you wrote that if AI is capable of recursive self-improvement, its source code, or at least model parameters and neural weights, would be subject to continuous change, making it impossible to claim that current AI is the same as original AI produced some time ago. In that example, who is responsible?
Right, so that's a big question. Are we talking about ownership in terms of who owns the startup or company, engineers designing it, users who kind of bought it as a service, AI as a service, just add your own goals and your own data? It's not obvious. If a system is human level or above, it is the one making decisions. No one could predict that it will make that exact decisions by definition. So we need to kind of reevaluate our concepts of responsibility. You cannot punish AI. You cannot put AI in prison. It's not meaningful in any way. So that's not an option. Then who is responsible? Saying that the developers are responsible is also problematic, because it's like saying parents are responsible for behavior of 30-year-olds. I mean, they're independent agents. They make their own decisions. You couldn't predict what they're going to do. You can kind of give them baseline of good ethics, but that's all you can hope for. And from that point on, they make independent decisions. The point of that paper is also that even if we wanted to find the owner and blame them, it's not meaningful. Legal ownership of something you cannot describe, you cannot kind of capture an instance of in a static way because it's so dynamic and changing, it's not meaningful. So claims of ownership in any case to get profits from it or to deny responsibility would not be meaningful, at least in terms of how we define legal ownership of products and companies and services.
Where do we go with this? It feels like there's equal parts, like this is really important, but also unstoppable, right? Like when you say there's all these crazies out here, someone's going to push that button. We can't just decide not to do something, Pandora only comes out of the box. She doesn't go back in. So again, you did mention earlier that you had kind of stopped short of proposing solutions. So I guess, can we just keep rattling off some more challenges? What are some more problems you've uncovered?
Well, it's kind of fractal in nature. For every solution we propose, even small patch for some sub-problem, we discover there is 10 additional problems with that solution. That new code kind of opens up additional attack surface. A lot of work, a lot of resources goes to developing more capable AI. Some people are now doing work on safety. They pick a specific subdomain and they work on it, but I think they would agree even if they succeeded 100%, that patch would not solve the big problem. I think we need a few more people looking at what is possible in this space, at least theoretically? Are we likely to solve those problems? Are there solutions before we try to either develop it or develop patches for the thing we're developing? Just it's standard approach in computer science. Is the problem solvable? Before you put all your resources, maybe it's one of those undecidable, uncomputable problems.
Certainly. It's hard to understand the implications before something exists, though, right? That's the thrift of the problem here. So does this mean just like better simulation, better like before something is let loose on a population or on a consumer base, really, that there's just a greater need for like, let's try and really understand the implication of our work beyond just sort of indulging in like with your own imagination, what might happen here? Is that a conceivable solution?
Well, there is some work in trying to understand what it is we want, at least. So to envision a good utopia, not like dystopia of science fiction where people never really wrote good heaven-like experiences. It's always boring and pointless, and you question why you're even doing that. So if we better understood what we're trying to build, maybe we would be more successful at getting there. I think right now most people would struggle to describe society they see as permanently good and they would be willing to accept without possibility of undoing it.
Yeah. I'm curious, Dr. Yampolskiy, when you think of deploying artificial intelligence and really being thoughtful of the implications of the tech, what are the use cases or even maybe organizations who you think are doing it above board in a meaningful, thoughtful way?
So OpenAI and DeepMind both are doing excellent work developing more capable systems and both have safety teams, but at the same time, it looks like they're trying to be as fast as possible at getting to more capable systems. So that's a bit of a conflicting position for me. I think places which are not explicitly developing more capable systems, but looking on specifically safety theory, places like Machine Intelligence Research Institute, to me, that's probably the best way to approach safety. They don't even publish certain results, or many results for that matter. They are more concerned about getting results than spreading it or getting others to cite them.
How familiar are you with the structure of those safety teams?
In terms of who's on them?
Or just in terms of how they do their work?
I have general knowledge. I never worked for one of them.
What's your sense of how they're lending themselves to these projects and the level of oversight that they're providing?
I think they get early access, but I don't think they are controlling what will be finally done or not done. I don't think they have that veto power.
If you were on one of those safety teams, what kind of questions would you be asking through the development process?
I would always try to compare our progress in developing versus our progress in developing safety mechanisms. At least from outside, it looks like there is exponential progress in capability and barely linear progress in safety work, which, of course, long-term is not sustainable.
Right. How would you measure progress in safety work?
Well, it is super difficult. We're still struggling in terms of measuring capability. IQ tests and such are very rudimentary tools. But I think if I ask someone to point to big breakthroughs in AI development, that easily give me 10 latest breakthroughs this week, we had this and that. Whereas in safety, I think people would struggle with big breakthroughs. They might point to that's when we recognized safety was important. This is when we recognized it was really hard. Maybe impossible, but I don't think anyone would be those are the top 10 amazing breakthroughs in safety.
Right. They're not as headline grabby, unfortunately.
Well, they don't exist.
Or they don't exist. That's exactly right. Well, Doctor, we are creeping up on optimal podcast length here, and I just want to, thank you for being here. This has been fascinating listening to you, and please keep up your research because it feels crucially important, and maybe we can speak again in the future, and you'll have lots more problems, I'm sure, but maybe we can get into some solutions as well.
That sounds wonderful. I hope to come back with a solution.
How AI Happens is brought to you by Sama. Sama provides accurate data for ambitious AI. Specializing in image, video, and sensor data annotation and validation for machine learning algorithms in industries such as transportation, retail, e-commerce, media, medtech, robotics, and agriculture. For more information, head to sama.com.